All right. All right. So as I've just mentioned just now, we will be learning about this periodic table part 2. So before we actually start the class, I would like to you can actually scan this QR code here for your handout so that we can discuss the question later, and you can use this handout to prepare your notes as well while listening to this class. Okay, so I'll give you guys 10 seconds, okay, to scan this QR code. All right, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. All right. Okay, if you didn't manage to scan this, our assistant will actually send this link in the comment section. Okay. All right. Great. Okay. So what to recall a little bit of what we have actually learned during the past weekend. Okay, we actually learned about 6.1 and 6.2, which is about mixture, right? 6.2, where we actually learn the separation methods, the definition. Okay, so we revise a little bit. Okay, here. All right. So do you guys still remember what is mixture and what is the difference between compounds? Okay, so I'll just revise a little bit here. Okay, so basically mixture is about mixing two or more elements physically. Okay, physically. But compound is about mixing two or more elements chemically. So this is the major differences between mixture and a compound. All right. So for example, mixture, we got hamburger. Okay, even burger is actually a mixture because we actually mix two different things together. For example, we got meat, we got bread, we got vegetables. So we just add them together and just using our hands physically combining them. Okay, so this is actually the very very lifestyle example, okay, that we have as a mixture. All right, so we actually also touch up a little bit about methods to separate the mixture last week. Okay, which is filtration, distillation, separation using magnet, sedimentation, flotation, sieving, and chromatography. All right, so filtration is more of like separating the mixture of a liquid and also an insoluble solid. All right, because we want to take yeah, that's why we got this real life example, which is using a separation between coffee powder and a coffee drink. All right, so we got distillation is about separating mixture of miscible liquid mixture. So basically it is about the different boiling point of the mixture where we will be using this method. For example, we got this perfume here. So for example, we need a 60 degree in order to extract this perfume, right? So we burn this fire until 60 degree and then we maintain it so that all the perfume mixture will be extracted out. And then when we heat it until 100 degree, maybe water vapor will out as well. So like we don't want water vapor, right? So we just want to keep the temperature at 60 degree to obtain the fragrant only. All right. Okay, so for separation using magnet, we got example here. For example, we got this iron fillings and we got sulfur here, which is the meaning of to separate two solid mixture in which one substances is magnetic. Because if we want to use magnet, that means another substances must be attracted to a magnet as well, right? So this is how we apply this knowledge. Okay, here. And then we got furthermore we got sedimentation method. Sedimentation method is more of like separating liquid and insoluble solid mixture. You might get confused with filtration because filtration also the same, right? We separate stone. For example, we got stone and we got water. We got sand or we got water. So one is insoluble and one is a mixture. So we just how do we separate them? We can actually use both. Okay, both are acceptable. We got filtration and we got sedimentation, but it depends on the situation. For example, if you want to make coffee, right? Takkan we use sedimentation kan? So maksudnya coffee powder tu tenggelam dekat bawah coffee tu. Macam mana nak minum kan? So tak sesuai lah. So kalau kita nak beza, kita kena tengok apa situasi yang kita nak guna. If in case we say this a sedimentation method, it is more of like our swimming pool. We got those leaves, you know, drop underneath, and then they just set it. They just they just leave it on the ground there. Okay, so this is how we differentiate the usage of different separation method. Okay. All right. So furthermore, we got flotation. Flotation, it's about floating lah, basically floating. Look at this baby, okay? So it's about separating soluble and insoluble water in material. So a fun fact here is that actually, in order for you to float on a liquid, it can be water, it can be oil, it can be soup, even the soup that you are drinking, or even like a Pepsi you are drinking. In order for the element to float on a mixture, on a liquid, okay, it must have a lower density than the liquid. Okay, so for example, you got oil here, right? Oil it actually has a lower density than water, and for ice as well. Ice, another factor. Ice on water, right? It will float on water, right? That means ice has a lower density than water. Even ice is made up of water. So this is, yeah, this is something like you can know. Okay, you can learn more about this. Okay. All right. So we got chromatography. Okay, so basically chromatography is the method used to separate a small amount of mixture and to test any harmful coloring in our food. So basically, I think this method is not so common, as it is not widely used, by the public, and we seldom touch this, but it is one of the method which I think it is you will learn furthermore, you will learn more detail in your later stage of education. Okay, so for now you just have to know this is about testing the harmful food coloring present in our food. Okay, so this is kind of interesting to see the rainbow color there on the paper. So it actually tests the different layering and different color in that food, okay, in the particular food. All right, so that is the conclusion of our whole revision of our on our last weekend, like what we have learned. Okay, so today we will proceed with 6.3 compounds. Okay, so compounds, right? To differentiate it from mixture, which is it is mixing two elements by chemically. Okay, so for example, we can see here. Okay, here we got this Mickey Mouse look of a compound, right? Basically, we can't actually put them together physically. If we put them together physically, that means it won't have this shape anymore. Okay, it might just be just like berselerak. Dia takkan ada shape form macam ni, macam a cube ke, atau macam dia punya formation macam dah kekal lah macam tu, sebab dia mixed by chemically. So this is the power of chemistry. Okay, power of chemically. All right, so we'll see in further details how this thing is formed. Okay, so for the definition of compound, first thing, it is actually consists of two or more elements mixed chemically. I have to repeat this chemically because to key in into your mind, to let you know this is about chemically, compound chemically, compound chemically. Okay, and the second one is that it has a specific characteristics for each compound. Okay, that means different compound they got a different characteristic. That means for example, we got water. Okay, and then we got another metal oxide. For example, you got iron oxide. Iron oxide is actually rusting. Okay, so we will talk about that further. Okay, so we got different characteristics. Okay, some are hard, some are liquid form, some are solid form. Okay, and then we got the most practical example of compound, which is water. Okay, you might wonder how come water is a compound. Okay, because water, it is actually the mixture of hydrogen gas and a hydrogen atom and also oxygen atom. Okay, that means we got this Mickey Mouse shape, right? Okay, that means water, right? It is this thing is the oxygen atom. Okay, the red color one, and then we will form with two hydrogen atom. That means two hydrogen gas atom lah. Okay, so you can imagine as this. So this is actually the water molecule. Exactly, the structure is like this. Just that we have to label this is oxygen and this is hydrogen atom. Okay, here. So yeah, so this is how the compound works. So actually the water, it looks like a liquid, but actually it is consisting of many small compound, okay, of that Mickey Mouse shape. Okay, all right, so let's look at how the metals and the non-metals work. They combine together to become a compound. Okay, so the combination of metals and non-metals. Okay, if we want to combine this, magnesium, aluminium, zinc, iron and copper, which is one of the element, okay, one of the element, 5 elements here, okay, and then we combine it with oxygen, which is one of the non-metal. Okay, metal dengan non-metal, apa beza dia sebenarnya? Kalau metal kan, metal dia macam besi, dia macam macam kata dia dia satu jenis of besi macam tu, okay. Tapi untuk non-metal maksudnya dia bukan besi. Okay, maksud dia bukan besi. Contohnya kita ada oksigen lah, kita ada gas-gas lain lah, okay. Macam hydrogen gas juga, non-metal juga, okay. So kalau kita campurkan lah, kita campurkan magnesium tambah oksigen. Okay, magnesium tambah oksigen kita akan dapat magnesium oxide. So kalau semua metal ni dia tambah dengan oksigen, semua dia akan ada ni, oxide. Dia akan jadi aluminium oxide, zinc oxide, iron oxide, copper oxide. Dia akan jadi oxide. Kenapa? Sebab dia tak ada tulis kat sini, tapi sebenarnya dia punya chemical reaction lah. Kau akan tanya, magnesium campur dengan oksigen, maksudnya saya guna tangan campur magnesium dengan oksigen ke? Bukan macam tu. Kita akan macam mana? Kita akan burn magnesium tu. Sebab dalam udara kita ni kan, kita ada oksigen. We got oxygen, right? When we breathe in oxygen. 20% of the content of this air is consisting of oxygen. So how do we actually mix these two metals and non-metals together is that we actually using this chemical method, which is burning, okay? We burn the magnesium so that the oxygen in the air can combine with the magnesium, and they will form magnesium oxide, okay? So this is a more detailed explanation, okay, so that I hope you can really understand this and you can visualize the reaction between them, okay? Basically, they just burn together, okay? They just burn with the air, so they actually eventually burn with oxygen, okay? All right, so furthermore, we got alkali compound. Okay, alkali compound, okay, to make this clear, okay, I think you guys might be confused at what is alkaline compound, okay. So we look back to our periodic table, okay. So actually this group 1, right, okay, this thing we call it as group 1, okay. This one call it as group 2. Basically each column, each row, okay, I've forgotten. I think it's row, right? I think it's row, okay. Each row, right, each column, I think it's column. Okay, column, yeah. Okay, each column, right, it is called group, okay. So you got group 1, group 2, group 3, group 4, group 5 here, okay. So that means alkali metal, it is this group 1, you see, okay, you see why, okay, alkali metal, we got what? We got lithium, we got sodium, we got potassium, right? Okay, we got these 3, okay. So let's see, this one, the first one is lithium, the second one is sodium, third one is potassium. So in case you can't, yeah, basically if you zoom in, you can see this small little word here. It's called lithium, sodium, and potassium, okay. So this is actually the alkali metal, okay, what we have learned during 6.1, okay, about periodic table. So actually we can also mix these alkali metals with water to actually release hydrogen gas. Okay, so this is one of the method that how you want to obtain hydrogen gas kan. So this is one of the method lah. You can mix alkali compound with water to produce lithium hydroxide. Just now is magnesium oxide kan. Sekarang kita ada hydro kat depan sebab kita mix dengan water kan. So kita ada lithium hydro. Hydro maksudnya water. Hydroxide tambah dengan hydrogen gas. Okay. So kalau dia alkali metal, tak kisah apa-apa alkali metal lah. Dia mix dengan water, dia akan dapat hydrogen gas. Okay. Tak kisah dia ni rubidium ke, dia mix dengan water, dia akan dapat hydrogen gas juga. Okay, ni dia punya satu karakteristik lah. Alright. Okay, so if you have any question, you can actually leave at the comment section so that we can answer you later. Alright, so moving on, we got iron and sulfur powder. Okay, if we mix them together, right, when we burn them, okay, this is how the procedure works, okay, how it works, how we burn them, okay. We actually use this tripod stand, okay, tripod stand, and then we got a Bunsen burner here, actually, Bunsen burner, and we got this crucible. It's like a mangkok like that lah, a white mangkok, a white small mangkok where we actually burn the sulfur powder, tambah iron powder kat dalam ni. Okay, we got pipe clay triangle kat sini juga, okay. Kita burn, okay, kita akan dapat apa? Iron sulfide. So if you realize, right, everything related to burning, to heating, we actually will get this okay? We got this okay? Here, okay? So you can see it is like a formula like that, okay? It's like a formula. All right. All right. So next, you'll see the methods to separate compounds. Okay. Methods to separate compounds. Okay. So just now we have learned like what are the characteristics of compound. Okay. How we combine two elements together to become a compound. So now we will be learning about how to separate the compound. Okay. On the other hand. All right. So one of the method we got here is called electrolysis. Okay, electrolysis, that means we use this this is the battery, okay, this is the battery here, and then we got this cathode here and not here, okay. These are two, yeah, two metals are okay, and then we got this beaker here, okay. So this is a solution. This solution we call it as electrolyte, okay, electrolyte. All right. So okay, because compound they bonded chemically, right? So if we want to separate them, we also need to use chemical method. Okay, for example, today we got chao kway teow. Okay, in case you don't like the vegetables in the chao kway teow, okay, you separate it using your chopsticks, right? You get rid of all the vegetables inside. Okay, but for compound, how? Compound we didn't mix it physically, so we must use a chemical method. Okay, so this is the idea of it. All right. So electrolysis, how does it work? Actually, it is by passing the electric current. Okay, so why we need battery here is because we need electricity. We need the electric current to pass through. Okay, to pass through. So actually, you can see right in this electrolyte, we got negative thing here, we got positive thing here. What are these? These are actually the ions, okay. We got positive ions, we got negative ions, okay. So basically if we got tambah tolak, you can see battery here so got tambah tolak kan. So kalau ada tambah tolak maksud dia satu cycle dah. Maksud dia daripada ni positif boleh pergi negatif, negatif pergi positif, positif pergi negatif, dia akan jadi satu circuit dah. So kamu akan macam kadang-kadang kau akan dengar macam water tu boleh conduct electricity kan. Sebenarnya kenapa? Sebab dia ada ni ion kat sini. Dia ada ion, sebab tu dia boleh conduct electricity. Walaupun dua besi ni tak ada connected, battery ni connected saja. Maksudnya ni macam broken circuit kan. Tapi sebenarnya dia boleh conduct electricity sebab dalam liquid ni dia ada positive dengan negative ion. Okay, so this is extra knowledge for you. Alright. Okay. So wait, hold on. Okay. So for example, we got this thing as water, right? So how do we actually separate them? That means we actually attract positive ion here at the negative side. We actually attract negative ion here at the positive side. So this is how we separate water. For example, we got water, right? This is the oxygen atom. This is the hydrogen atom. Okay. So now we separated them already. You see, they're moving here, moving here. So this is how we separate them. Okay. A brief idea. All right. So talking about now we'll be talking about differences between physical and chemical change. Okay. So what are the differences between them? Okay. For physical change, right, we do not form a new substances. Okay, we do not form a new substances. Okay. Physical, that means macam mana kau campur, macam mana kau campur kuih tiaw, masih kuih tiaw. Okay, in the end, kuih tiaw. Okay. So a more practical example, we got water. Okay, water, right? We go put into fridge. We go freeze it, so it become ice. Okay, and later we melt it, it become water again. And then later we go boil it, it become vapor. So in the end, does it form a new substances? No, it is just undergoing a different physical stages. Okay, just another form of existence only. Okay, we got ice, we got water, we got vapor, water vapor. In the end, tiga benda ni water, sama, dia punya elemen sama, dia kekal sebagai elemen dia, water. Okay, tetapi kalau untuk chemical change we will be forming a new substances from a original substances. Okay, that means for example we got this rusting of iron. Okay, contohnya kita ada iron kat sini. Okay, ni putih punya iron kan, kita letak cat atas dia, besi ni, kita letak cat putih. Tapi lama-lama kemudian ada hujan, acid rain, ada expose dengan oksigen kan, dia akan buat dia rusting. Okay, dia akan buat dia rusting. So ni nampak tak? Ni karat-karat berkarat ni brown color. Sebab dia akan ada satu chemical process chemical process yang akan buat antara besi dengan oksigen tambah air. Okay, so this is why we call it as a chemical change because it totally becomes a different thing already. Okay, takkan kita ingat takkan kita ambil karat besi berkarat sebagai besi lagi kan? Dia bukan besi lagi sebab ni tak ada fungsi dah. Sebab memang kalau benda tu berkarat dia akan lebih ni tak berfungsi lah sebagai besi yang baru lah. Okay, alright, so moving on, we got this comparison between physical and chemical change Okay, so if you look at this, wah bulat-bulat macam sangat confused sangat confused, macam banyak perkataan ni tak boleh faham Okay, tak apa, kita buat simple. Okay, kita tengok. Yang penting kita kena tahu 4 faktor saja. Okay, yang pertama, the new substances. Does it form new substances or it does not form new substances? Okay, kita tak perlu hafal ni, kita faham je. Okay, untuk physical change, dia takkan form new substances kan. So kalau kau ingat physical change, kau ingat balik water, ice and vapor. Okay, kalau kau ingat chemical change, kamu ingat balik yang berkarat tu, besi berkarat tu. Okay, so this is how you answer the first criteria already. New substances will never form in physical change, but chemical substance, yes. Okay, what about properties? Okay, the properties of the substances remain the same or different. Okay, kalau untuk physical change, kalau water vapor dengan water tu properties dia sama je. Properties dia sama untuk nak minum sebab dahaga. Okay, kalau untuk chemical, okay, kereta kita orang ni, contohnya kita ada Myvi. Okay, kita ada Myvi yang baru kita semua nak kan. Tapi kalau saya bagi kamu ni Myvi berkarat, kamu nak ke tak? Tak nak kan? Sebab kamu tahu ni tak fungsi lagi. Okay, dia akan ada lubang ke, ada apa-apa benda lagi ke, lebih ni tak fungsi dah. So maksudnya properties dia dah berubah. Okay, so what about chemical composition? Okay, chemical composition for physical change, right? Basically, it is still remain the same. Maksudnya elemen dalam tu masih same ke tak? Masih sama shape, masih sama position ke tak? Bagi water sama. Okay, bagi water sama. Tapi untuk metal, besi tu tak sama. Sebab kenapa? Sebab besi tu dia telah campur dengan oksigen. When the metal rusts, right, it actually becomes metal oxide already. Okay, ferrum oxide. So this is why the chemical composition is already undergo changes. Okay, for that, because it already added an oxygen element inside. Okay, and then the next factor we got energy. Okay, do physical change need energy or chemical change need more energy? Okay, physical change we need energy as well. Okay, with chao kway teow we need energy as well, but we need a lesser energy. For chemical change, right, we need a larger energy. We need battery, we need electricity, we need a burning, we need some more complicated, more complicated stages, in order to do that. All right. Okay, so I hope this helps you. Okay, so this is actually the table that I'm talking about. Okay, the formation of new substances for mixture and compound. Okay, mixture, no. Okay, compound, yes. Chemical bond, no. Okay, basically mixture is like air lah. You just think it as air, think it as besi. Compound, think it as besi. So no, yes. Okay, separation method. This one is physical. Water kita guna mixture. Contohnya mixture water dengan batu. Physical. Kita guna physical method. Tapi untuk compound, rusting. Dia punya rust. Dia telah besi yang telah berkarat tu. Kita nak separate dia macam mana? Guna chemical method. So kita tak boleh nak guna tangan macam nak cabut macam mana. Macam mana nak buat? Takkan boleh buat kan. So next we got properties. Properties, mixture still the same because you just campur them physically. Okay. Batu dengan air maksudnya air batu. Itu saja. Kalau compound we campur oxygen atom dengan hydrogen atom, dia akan jadi apa? Jadi air. So this is like a miracle, When you're mixing oxygen and hydrogen, you don't mix it physically, you don't bind them together, but you undergo how do we say? Yeah, just like a bonding. Okay, we bond them together and will become water. Okay. All right. So basically, this is the end of my sharing session. Okay. All right. So before I end, we actually will need to proceed to our question. Okay. But before that, I just think we can have a 2 minute breaks first. Okay. Break. 2 minute breaks. Okay. 2 minutes break. All right. So we'll see you guys later. All right. So in case you haven't got your notes, okay, you can assistant can send it again, okay, the link there and our comment section so that you can get yours now. Oops. All right. So my assistant already helped us. It is already at the comment section. Okay. In case you guys haven't got, please access it now. Okay. All right. So I think time is out. Okay. So we shall proceed. All right. If you have any question, you can just actually leave at the comment section so that we can answer it later sekaligus. Okay. At the end of the session. All right. So for the first question, today we'll be looking into two questions only. Okay, simple. Okay, two questions. Focus question pertama, kita akan tengok method to separate mixture. Okay. Question one. Noraini wants to make pineapple juice. Using the recipe. Using the recipe given by her mother as shown in figure 1. Okay, so here is the keyword. Dia nak buat pineapple juice, pineapple jam, sorry, bukan juice pineapple jam. Okay. Kalau kita nak buat pineapple jam, pertama step dia remove pineapple skin, betul. And then lepas tu dia grate the pineapple. Okay, dia blend pineapple tu, dia blend, jadi dia halus sikit. Lepas tu dia remove excess juice. Okay, remove excess juice ni kita nak fikir macam mana dia nak remove lah. Okay, lepas tu kita dah cook the blended pineapple on medium heat. Okay, add some sugar, stir the mixture, and cool the jam. Okay. Okay, so daripada 6 steps ni, kita boleh tengok yang mana kita perlu apply kita punya knowledge about separation of mixture. Okay, kalau kita remove skin, perlu ke tak? Tak perlu kan? Sebab dua ni macam guna pisau je. Okay, blend tu maksudnya tak perlu juga. Tapi untuk remove excess juice daripada pineapple ni perlu ke tak? Sebab dia satu process of like squeezing kan. Kita nak mixture, kita nak tu pineapple saja, kita tak nak tu juice kan. So one of the method of separation dah lah. Sebab kita nak separate benda dah. Okay. So name the separation method used in the recipe. Okay. Kalau kita tengok ni. Okay. Separation method. Apakah separation dia? Kalau kita nak separate air dengan solid. Air dengan solid. Okay, maksud filtration. Okay, so which steps involve the separation method that you stated in 1A? Okay, maksudnya tadi sudah cakap kan? Ni step 3. Remove the excess juice. Okay, step 3. So you can write down your answer. I'll give you 10 seconds. Okay. It's quite simple, okay, for this question. All right, so let's proceed with the second question. Okay, the second focus question, we'll be learning about method to separate mixture. Also, we'll be focusing on the same type of same category. Okay, method to separate mixture. But this question will be a little bit challenging. Okay, it is a little bit K-but here. Okay, so Sandy is given a mixture of sand, iron fillings, sawdust, and salt. She separates the mixture by the following 4 steps in figure 2. Okay, the letters A, B, C, D represent the substances in the mixture. Maksud dia, A, B, C, and D representing sand, iron filling, sawdust, and salt. Tapi kita tak tahu yang mana. Yang mana A lah, salt ke, sand ke, iron filling ke, kita tak tahu. Okay, so kita nampak. Kita tengok soalan ni. Step 1. Magnetic attraction. Okay, magnetic attraction, lepas tu kita akan dapat satu A ni keluar. Okay, kalau kita guna magnet kan, kita fikir magnet dia akan attract apa? Dia akan attract metal yang ada magnetic characteristic kan. So kita akan attract benda ni, maksudnya A ni ada magnetic characteristic. So kita tengok sand, iron filling, sawdust and salt. Yang mana ada magnetic characteristics? Sand tak ada kan, iron tak boleh nak attract kan. Sawdust ni macam tak boleh juga, salt juga tak boleh, tapi iron fillings boleh kan. So maksudnya kita ada jawapan lah, A lah iron fillings. Okay, so kita proceed. B, C, D. Okay, B, C, D dia dissolve in water and remove substances that float. Okay, dia campur dengan air kan, so maksudnya C dengan D ada air dah. Lepas tu B dia float. So B dia float. Kalau float, kita tengok tadi iron filling dah cancel out dah ada dah A dah. So yang mana boleh float? Sand tak boleh kan, sand tenggelam. Sawdust macam boleh kan. Salt macam dah melted dalam air kan. So kita ada jawapan dia, sawdust. B. Okay, B ialah sawdust. Okay, lepas tu kita ada C, D, water. Kita guna filtration. Filtration maksudnya kita nak ambil yang benda yang solid dengan mixture, kita nak separate dia. Okay, so maksudnya kita telah separate C ni keluar. Maksudnya C ni ialah either mixture or solid. Tapi sekarang kita water kat sini. So maksudnya ni ialah mixture dah. Tapi ni C keluar. Maksudnya ni C. Tinggal salt dengan sand. Yang mana solid? Yang mana insoluble in water? Yang sand kan? Sand tak soluble. So sand keluar. Sand C. Okay, lepas tu kita ada salt dengan water dah. Maksudnya D ialah salt lah. Salt dengan water. Okay, so kita proceed dengan soalan pertama dulu. Identify the substances A, B, C, D, whether they are sand, iron filling, sawdust, or salt. So tadi jawapan semua dah jelas kan. Maksudnya A ialah iron fillings, B ialah sawdust, C ialah sand, D yang last kali ialah sand. Alright. So kita proceed dengan soalan kedua. Differentiate the density of B and C and why B can be separated from the mixture in step 2. Explain. Okay, so kita tengok apakah B dengan C dulu. Okay, B ialah sawdust, C ialah sand. Okay, density between B and C. Why can B separated from the mixture in step 2? Okay, kenapa B boleh separate? Alright, so kita jawab. Kalau density, B ni sawdust, C ni sand. Maksudnya sand dia lebih berat kan, sebab tu dia tenggelam dekat air kan. Sawdust dia float, maksudnya dia lebih lower density lah, lebih ringan kan. So maksudnya B is less dense than C. Okay, lepas tu dia nak apa? Dia nak why can B separated from the mixture in step 2. Explain. Kenapa B boleh separated dengan water? Kenapa dia boleh float? Okay, kita explain. Okay, sebab B ialah sawdust kan. Okay, because B is less dense than water, so it floats on water. While C is denser than water, therefore it sinks in water. Okay, maksudnya kalau in order for something Hello, hello. Okay, I'm so sorry. I'm so sorry for the technical issue just now. I didn't know I went off. Okay, so okay, I'll talk about this question B again. All right. So basically, question B, it talks about differentiate the density of B and C. Okay, so we answer this first. Okay, B is sawdust, dia float. C dia sand, dia tenggelam. So maksud dia B is less dense than C lah. Okay. Okay, so the second part, why can B be separated from the mixture in step 2? Explain. Kenapa B boleh separate? Kenapa dia boleh float ah? Dia boleh float dekat water. Explain. Okay, maksud dia B ialah sawdust kan. In order for something to float on water, contohnya kita ada ice ah. Ice dia mesti less than, dia mesti lebih ringan daripada water. Baru dia boleh float. Kalau dia nak tenggelam, maksudnya dia kena ada denser. Maksudnya dia lebih berat. Contohnya kita ada batu. Batu dia tenggelam. Okay. So, why B floats? Because B is less dense than water, so it floats on water lor. And why C, while C is denser than water, therefore it sinks in water. Okay. Alright. So kita ada C, kita proceed dengan C. If D is replaced with sugar, can it still be separated from water by applying step 4? Okay, kita tengok dulu apakah D. D tu ialah salt kan. Okay, kalau kita replace salt dengan sugar, can it still be separated from water by applying step 4? Step 4 ialah evaporation of water. Okay, kalau evaporation maksudnya kita akan tinggal salt saja. Sebenarnya application ni kita guna dengan macam mana kita nak extract garam daripada laut. Okay, garam sebenarnya dia extract daripada laut. Maksudnya kita ambil air laut, lepas tu kita jemur dia. Kita jemur dia maksudnya kita tak nak air. Air semua akan jadi vapor, lepas tu tinggal garam saja. So, can it be replaced with sugar? Okay, maksudnya kalau kita nak guna air gula, boleh ke tak? Boleh dapat gula ke tak? Sebenarnya, boleh. Konsep dia sama. Okay, so yes. Alright. So D, is there another way that Kumata could do to separate the mixture in step 4? Explain your answer. Okay, maksudnya dia tak nak guna jemur punya method, dia tak nak guna evaporation punya method. Ada apa method lain ke tak? Sebenarnya ada. Kita ada apply, kita ada belajar kan. Kita ada filtration, separation, magnetic, sieving, distillation, sedimentation dan banyak lagi. So contohnya yang kita boleh guna ialah yes, she can use distillation method. Okay, distillation maksudnya kita guna different boiling point punya mixture kan, miscible liquid mixture kan. So the boiling point of water is lower than salt. Okay, maksud dia kalau kita nak boil water, kalau kita nak buat water tu evaporate lah, kita just guna 100 degree Celsius cukup dah. Tapi bayangkan untuk salt, kita guna 100 degree Celsius cukup ke tak? Boleh buat dia cair, boleh buat dia keluar vapor ke tak? Tak boleh kan? 100 terlalu rendah. So maksud dia, boiling point of water is lower than salt. Therefore, only salt left after water is evaporated. Sebab salt ni sebenarnya dia compound. So kalau compound dia punya boiling point dia lebih tinggi. Maksudnya contoh kita perlu 500 degree Celsius baru boleh cairkan dia. Baru boleh cairkan salt. So kalau kita masak kan, kita masak kuali kan, kita masak sayur kita letak salt kan. Maksudnya api tu lebih tinggi daripada 100 degree Celsius, lebih tinggi, jauh tinggi. Baru salt tu boleh melt. Kalau untuk air, simple je. Air rebus sikit je boleh boil dah. Sebab dia senang lah boil. Dia 100 degree Celsius je. So itulah konsep dia. Distillation method kita boleh guna. Alright. Okay. So I think that's all. That's all for this question. Alright. So we will proceed with our Q&A session right now. Okay. So if you have any question, you can leave it at the comment section. And I really hope this session has benefited you. Okay, you have learned something from it. I'll give you guys 2 minutes. Okay, to leave the question. If not, we shall end our session here. Alright, I think that's no question so far. So I hope you guys are clear on this session. Okay, if you have any any question further, or next time you want to ask any question, you can actually leave at the comment section. So we will actually look into every single comment, okay, that you guys commented. All right. So we hope this sharing session has helped you, and don't forget to fill up that feedback form. Okay, it means a lot to us. And also don't forget that later at 4 p.m. we have the math session. All right. So if you want to know more, don't miss out. Okay. We hope to see you later. All right. See you. Thanks, guys.